Hey there, data enthusiasts! Welcome back to our channel. Today, we're diving into a fascinating topic that sits at the heart of machine learning, supervised and semi-supervised learning. Whether you're a beginner or just looking to brush up on your knowledge, we've got you covered. So grab your notebooks, because we're about to break this down. But before we get into the nitty-gritty, let me ask you this. Have you ever wondered why some AI models perform so well with just a small amount of labeled data? What's the secret sauce behind their success? Well, that's where supervised and semi-supervised learning come into play. Let's start with supervised learning. In simple terms, supervised learning is like having a teacher. You feed the machine a dataset that includes both the input and the correct output. This way, the algorithm learns to map inputs to the outputs. For example, imagine you're training a model to recognize different types of fruits. You might provide it with images of apples, bananas, and oranges, along with labels indicating which fruit is which. The model learns from these examples. When it sees a new image, it can predict the fruit based on what it learned from the label data. A classic algorithm for supervised learning is linear regression, which predicts a continuous outcome. If you wanted to predict house prices based on features like square footage, number of bedrooms, and location, you could use linear regression to train the model on historical data where the prices are known. Supervised learning is powerful but requires a large amount of labeled data, which can be time-consuming and expensive to gather. This is where semi-supervised learning comes in. Now, let's talk about semi-supervised learning. As the name suggests, it's a middle ground between supervised and unsupervised learning. In semi-supervised learning, we have a small amount of labeled data and a larger amount of unlabeled data. Think of it as a teacher guiding you, but also allowing you to explore on your own. For instance, let's say you have 100 images of fruits, but only 10 of them are labeled. Instead of discarding the other 90 unlabeled images, you can still use them. A semi-supervised learning model leverages both labeled and unlabeled data to improve accuracy. A common algorithm used in semi-supervised learning is the self-training approach. Here's how it works. The model is initially trained on the labeled data. Once it has learned, it makes predictions on the unlabeled data. The most confident predictions are then labeled and added back into the training set. This process continues iteratively. One shining example of semi-supervised learning is Google's image classification. When they launched their image recognition system, they had millions of unlabeled images. By using semi-supervised techniques, they managed to significantly improve the model's performance without needing to label every single image manually. Now, let's summarize some key differences between supervised and semi-supervised learning. First, regarding data requirement, supervised learning relies entirely on labeled data, whereas semi-supervised learning uses a mix of labeled and unlabeled data. Second, for efficiency, semi-supervised learning is often more efficient in terms of resource utilization, as it makes use of unlabeled data that would otherwise go to waste. Third, concerning accuracy, in many cases, semi-supervised learning can achieve higher accuracy than supervised learning alone, especially when labeled data is scarce. To put it simply, supervised learning is great when you have lots of labeled data, while semi-supervised learning shines when you have limited labels but a wealth of unlabeled data. It's an exciting area that opens up new possibilities for machine learning applications. So, there you have it. We've explored the fundamental differences between supervised and semi-supervised learning and how each approach has its unique strengths. Whether you're building a model for image recognition or predicting the next big trend, understanding these concepts is crucial. If you found this video helpful, please give it a thumbs up and share it with your friends. Don't forget to subscribe to our channel for more exciting content on data science and machine learning. And if you have any questions or topics you'd like us to cover next, drop them in the comments below. Thanks for watching, and until next time, keep learning.